Okay, let's solve this problem. LeetCode75 sort colors. So for this problem, let's see. Given an array names with n objects colored red, white, or blue, sort them in place so that objects of the same color are adjacent, with the colors in the order red, white, and blue. So we will use the integer 0, 1, 2 to represent the color red, white, and blue. So we must solve this problem without using library sorting function. So the library sorting function means that just sort, like for example, we use a merge sort or whatever. So sorting an array. So for this problem, so for this problem, so first let's talk about this problem. So first we can actually use merge sort or quick sort. Okay, or quick sort. But the time complexity for the merge sort or quick sort is going to be n log n. Okay, so this is time complexity for this one will be this. Okay, and also we can make it better. And the second solution we can use a bucket sort. So basically, bucket sort, how bucket sort do? So bucket sort actually, because here we have a 0, 1, 2, 0, 1, 2. So we have a bucket, okay? The bucket, we can count the number, the bucket, we have 3 elements, 0, 1, 2. And then when we iterate the numbers, we count the zeros, ones, and twos. So this is basically what they do. So bucket sort actually can have a linear time complexity OM because we know we only have 0, 1, 2. So, but we need a hash map. We need a hash map, and then it's gonna have extra memory. So the time complexity for this one is gonna be O N O. It's gonna be O N. But the bucket sort we usually have a extra. We have a extra space. So because we use a hash map, okay. So that's why this one is not a good one, okay. So however, because this one, because of this problem, this problem is a little bit different because we can count the numbers without hashing map. Okay, we can count. We can count 0, 1, 2 without hash map. Okay, so we can actually count it. So basically, what we do, the count zeros is a number of zeros. Okay, and also we can count ones. We can also count twos. Okay, so we can count all this. Okay, and then we just replace the number of 0 into, we can replace zeros into array here. We can do, oh, it's numbers. Here is numbers. Okay, we can replace this to 0. Okay. And also we can replace ones into numbers. K plus 1, 2k plus m. Okay, we can replace 2's into numbers like k plus m plus 1 and num star length minus 1. Okay, this is basically the algorithm. So the time complexity for this problem, the time complexity will be O(n), because we actually did twice. We did twice the iteration. So first, when we build the bucket, so we pass it through once, and then we replace 0, 1, 2. So we pass it through twice. So it's O(n) actually equals to O(n). Okay. Okay. So the space complexity is O(1). Because we don't have extra. We don't have extra. We just used. So whenever we are talking about in place, whenever we're talking about in place, that means we can also use. That means we can use a swap. Okay. This is this method. However, we can actually pass through once to implement by using quicksort. It's a kind of a quicksort, but not because this one only have 0, 1, 2, right? So this quicksort is a little bit simple. It's very easy quicksort. Like an easy quicksort. Okay. So what we do for this one, we can actually the quicksort start from 0, like L minus 1. This part, actually, we let this part equals to 0, and this part, like L, like R, the right portion, and this part equals to 1. And then this part, R plus 1, like the length, the length minus 1. Okay, this part equals to 2. This is basically idea. Okay, so let's give example for let's give this example. This one is input numbers here. Okay, so this is what we have, and then we make it easier. We make it a little bit like this. Okay, so for this problem here, here's L, and here's R. Okay, here's L, here's R. So because it's in place, so we're gonna use the swap. Okay, swap. So whenever we're talking about in place, we need to think about this. Okay. Okay, so how we do? So we start from iterate. We start from I equals to left. Okay, we start from left, and then we check if this one equals to so here equals 2. So what we do, if equals 2, we just swap this one, swap the I with R and R minus minus. Okay, so it's gonna be like this. It's going to be like this. Here is 0, here is 2, and then the R we minus minus. Here minus 1. Yeah, here. Okay. Notice here the index I we don't add plus plus because we need to check this element in the R when we swap to here. So and then we check 0. Yeah, it's equals 0. And then in this way, if equals 0, then we swap L the left and I and I plus plus L plus plus. So after this one, so what we get after this one? So it's going to be swap. The R we don't swap the R. Okay. So no, actually, here is we just swap because L and R is equal, so swap is gonna be the same, and I plus plus L plus plus, and then we check this 0 is equals to 0. Then we swap I and L because they are in the same position, so it's gonna still be here, and then I plus plus L left plus plus. So what we do is gonna be like this. Okay, the L will be here. Okay, and then we check this one is 2. Okay, equals 2. So we swap this I and R. So and then R minus minus. So what do we do after here? What do we got? We will get the I we don't change, and here it's gonna be 1. Here is gonna be 2, and then the R will be here. Okay, and then we check the I equals to 1. So it's not equals to 0, it's not equals to 2. So we just do I plus plus. So this one will be okay, I plus plus to here, and then we do again I plus plus. Okay, so when I greater than the right, then our while loop is stop. Okay, this is basically the idea. Okay, the algorithm. Okay, let's code. Let's code this problem. It's a very easy one. Okay, so what we do, we just do left equals to 0 and right equals to numbers length minus 1. Okay, and I equals to 0, and we do a while loop. While loop I smaller equals to right. Okay, when smaller equals to right, so what we do, we check if the numbers I equals to 0. So if equal to 0, we're gonna, what we do, we're gonna swap numbers. Here is I plus plus and left plus plus. Okay. Okay. Else if numbers I not here. Else numbers I equals to 2. What we do? We just do swap numbers I here is the right minus minus. Okay, and then else, otherwise if equals to 0, right, in this case I plus plus. Yeah, this is basically the problem. And then let's write a function of swap. Okay, how to do the swap function? Let's do this private, so we don't have to return anything. So here is a void, we just need to swap. Okay, we don't need to return anything here. So here is gonna be, this is the input is numbers and input I, input J. Okay, and then after this, what we do, we define a temp. The temp actually, we give the I to the temp. Okay, and then what we do, we give the J, the numbers J to the I. So basically what we do here, we just actually store the numbers I to the temp, and then we give numbers J to the I. Because if we don't have the temp, we directly give the numbers J to numbers I, then we lost this one, right? So that's why you use the temp, okay? And then numbers, here is J, and equals to temp. Okay, here it should be like this. Okay, let's run the code. The temp complexity for this one, did we talk about that? Yeah, the temp complexity for this problem is ON. Temp complexity for this problem, just ON. We just pass through once. Okay, so the space complexity is O1. Okay, let's run the code. Okay, let's see here. What's the problem? Come from the symbol. Okay, here is names. Sorry, that's the wrong tab. Okay, it's accept. See the test case. Okay, let's put this test case to run again. Okay, it's accept. Okay, let's submit. Okay, the runtime is 1 ms, faster than 35% of Java online submission. Okay, thank you for watching. I'll see you next time.